So this is our cloud computing and IoT project. As you can see, we have created a remote controllable foosball goalie. And to do this, we've used two servos, one of them controlling the side-to-side movement and one of them controlling the kicking movement. We've hooked all of those up to an Arduino board. And for sensors, we have a contact sensor for when the ball touches each player. And we also have a goal sensor every time the ball rolls through the net. So starting over at the mechanical end of things, we have a rack and pinion mechanism that we 3D printed. And this is going to be moving our bar forward and backwards for the side-to-side movement. And you can see both of the servos are attached to another 3D printed part, which essentially just brings them together into one unit. And then that unit is going to be attached to this slider so that everything moves nice and smoothly back and forth. And moving on to the electronic sensors that we have these three contact sensors. So you can see every time one of these sensors is pressed, the players will kick automatically. And this is within our automatic mode. And then we also have a goal sensor, which works along the same principles, just two pieces of metal contacting. Every time they contact, it senses a goal. And this is done by just the ball rolling into the net and then falling on the contact sensor like that. So now we'll demonstrate the workings, starting in automatic mode. So we're there right now.
As you can tell, when I move the movement slider back and forth, the entire system will move back and forth. The automatic kick will then trigger contact, which automatically kicks as previously discussed. And I can also switch that into manual mode, where a button will then trigger the kicking mechanism. We can also switch it over into UV dots mode, so we can control the movement as well from UV dots itself. And our score value is updated in real time based off connection with the sensor.
So some of the issues we had with this project that we had to overcome were, number one, a low amount of power to both of our servos. So the 5 volts directly from the Arduino was not quite enough to create a fast movement. So what we did to overcome this was attach a external power supply set to 5 volts. And that's just going to be powering just the Arduinos, and everything else will be running off the just the servos. Everything else is running off the Arduino power supply. And that allows us to have a much faster side-to-side movement as well as a kicking movement. And then another problem we had was with our sensors. As you can see, these are not regular sensors. These are homemade. We just use aluminum foil and wires and tape. And the reason we did this is because the sensors that came in our kits were a little bit too hard to press in. Like the push buttons were too hard to press. So what we did was have very sensitive push buttons here, as well as in the goal sensor. We tried to use a tilt sensor, but that was a little bit too sensitive as well. So instead we just have a contact sensor, which essentially works the same way. So some of the issues we had on the software side of things were with our digital sensors. When they were plugged into digital pins, we were getting random spikes of small voltages, which would trigger our digital pins and therefore trigger our kicking or our goal sensor. So what we did to overcome this was plug them into the analog sensors and then run a loop that would check these voltage values very quickly. And then every time we have a voltage value that is higher than, or as high as what we expect, rather than just a small voltage value, then that would output a Boolean so that we could base it off of that rather than any voltage value.